We're going to talk now about discrete probability distributions, and let's do it this way. Why don't we let x, now that's a capital X, hard to tell when we write it like this, but let x be a discrete random variable. Now, you may remember in the last unit we had two examples. The first one was counting the number of yes answers to our question, have you ever flossed your teeth with your hair? All right, so x would be a count. X could be, in that case, 0, 1, 2, 3, 4, 5. All right, so suppose it doesn't have to be exactly that problem now, but let x be a discrete random variable where we're counting something. And suppose that x can assume the values. All right, now I'm going to write them like this. It could assume a first value, a second value, a third value, dot, 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 maybe a kth value. So like in that last example with the flossing the teeth example, this might be the 0, the 1, the 2, 3, 4, 5. So we're saying that let x be a discrete random variable, and suppose x can assume these values with probabilities. All right, how about P1, P2, P3, dot, 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 P sub k. So all we're saying here is this. You got a random variable, a discrete random variable. It can assume these values. This one with this probability. This value with that probability. This value with that probability, and so on. All right, we can list these. Okay, maybe we could list it like this. The probability that the random variable x equals the value x1 is equal to P1. Now I'm going to do this with a numerical example, but I want to do it in general first. So the probability, here's what this means, okay? This means the probability, I'll abbreviate, the probability that the RV, random variable, x equals the value x1 is P1. All right, that's what that means. So you can almost read it here. The probability that x takes on that value is P1. So P1 is the probability that x equals that x1 value. And then we could say the probability that x equals x2 is P2, and we could just keep listing them all until we've got them all. The probability that x equals x sub k is P sub k. But we could also list them in a table, all right? So I could write something like this, x p of x, and this is a little bit more common. So here's the values that x could be. x1, x2, x3, dot, 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 up to x sub k. And these the corresponding probabilities, P1, P2, P3, dot, 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 P sub k. Now, these listings are called, there's a name for these. These listings are called probability distributions. Probability distributions. And we call them probability distributions because what I'm doing is I'm distributing these probabilities to these x values. Now, in that example one where we had x could be, all right, so for example here, x could be one of these values, right? 0, 1, 2, 3, 4, 5. How many people in your sample of 5 could say, yes, I flossed my teeth with my hair? Well, x could be any one of those values. So I might write something like this. I write the x value, I write the p of x value, and then I write 0, 1, 2, 3, 4, 5. And then I have to somehow compute these probabilities. Now, we are going to do this a little bit later in the section. All right, so I'm just going to put these values in, but we'll see where they come from. All right, so the probability that nobody says yes might be 0.6957. We'll see where that number comes from later. Probability that one person out of your group of 5 says yes, I've done that. That's 0.2618. Probability that 2 people say yes, that is 0.0394, so 0.0394. The probability that exactly 3 people say that is 0.0030. And 4 people, 0.123 zeros and a 1. And that all 5 people in your group said, yeah, I've flushed my teeth like that, is 1, 2, 3, 4, 1, 2, 3, 5 zeros and a 2. So these are probability distributions. We're distributing probability to the values of the random variable. So now what we're going to say is this. In this first example, now the first example was that was the flossing teeth with the hair example. So in that first example, there is a 0% chance of randomly selecting 5 people and asking them yes or no and getting 6 yeses, right? That cannot happen. And there's a 100% chance of getting one of these numbers, right? 0, 1, 2, 3, 4, 5, right? One of those is going to come up. So 0 chance that it could be 6 yeses, 100% chance it's going to be in that group 0, 1, 2, 3, 4, 5, or 6. So probability is a number that is going to be between 0 and 1, right? 0, nothing happens, can't be. 100% chance something's going to happen. So probability is going to be some number in that range, right? So if I could actually write that and say this, 0 less than or equal to p, the probability of x, less than or equal to 1. Right? Probability is going to always be in this range right here. We're going to go from 0, nothing happens, to 1, something for sure happens. So I find it helpful to think of probability as being one square unit. All right, so just one on each side. So right here is one square unit of probability. And the primary goal in probability theory is to determine how to divide up this 1 unit square. I got 1 square unit of probability. How do we divide that up and distribute all the pieces to the outcome of an experiment? What we're thinking is this. How do I divide this up and distribute it to the values of the random variables? Here's an example that goes right along with the hair and flossing example. So the random variable x, this is, remember, the number of yeses that you get when you ask a group of 5 randomly chosen people, have you ever flossed your hair with your teeth? So how many could say yes? Well, 0 or 1 or 2, 3, 4, 5. And then I came up with these numbers, and I'll show you how to get those later in the section, later in the section. Now, here's the idea. Here's that 1 square unit of probability. Okay, so what I'm going to do is I'm going to take just about 69.57% and distribute it to the 0. Then I'm going to take about 26.18%, that might be this much right in here, and distribute that to the 1. Then I'll take about 3.94%, that might be this little region right here, and distribute it to the 2, and so on. Then I'll take about 0.3%, right, very small, can't even see it here, that would be like just that little slice there, and put that with the 4, all right? And then the rest of it with the 5. Now, where we're headed with the rest of the course is this. We're dealing with probability distributions. So what we could do is we could take that 1 unit of probability. Now, the way we wrote it here is I wrote it as a square. All right, and that's 1 square unit. But it doesn't have to look like this. It could look like this. Maybe it looks like this. And I'm going to divide that up somehow. So this is also 1 square unit. But I might have something that looks like this. All right, one that looks like that. And that would be 1 square unit. So different probability distributions will have different shapes for our 1 unit of 1 square unit of probability. And then we just need to come up with a way of dividing it up and assigning those values to the random variable. So what we're after when we can is this. We would like a rule that assigns a probability to each value of the random variable. Like this. I've got these random variables, values of the random variable, and I would like a rule that does this division for us. So that rule is called a probability function or probability distribution. Same thing. But we would like a rule that does this for us. All right, so we're looking for this, and we'll see this a little bit later on. Now, the rules that we're talking about, these are just like the functions you saw back in your algebra course, but we wrote it like this. F of x equals, something with an x in it. But now we're going to write p of x. We're going to name the function p for probability, and so something over here, that has x's in it. And it's going to be that same distribution that we just saw, that function, this function here, that we're going to develop, that we're looking for to make these assignments, has to satisfy these two conditions. Every output, right, put in a value of the random variable, compute, you get an output, which is a probability. That probability has to be between 0 and 1, and when you add up all the probabilities, you have to get exactly 1. That's the function we're looking for.